Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on September 1st, 2025, which was about 3 days ago. The big result is a single vision and language model that unifies robot reasoning, long horizon planning, and natural dialogue, and it outperforms both open source and commercial baselines in interactive task execution. The paper is titled Robix, a unified model for robot interaction, reasoning, and planning. And as we will see later, the implications for embodied AI are quite significant. It brings proactive dialogue, interruption handling, and common sense reasoning together through chain of thought training plus reinforcement learning. Alright, Figure 1 illustrates how the model conducts an entire interaction loop, which means it reasons step by step, talks with the person, and issues atomic actions to the low-level controller for execution. The panels track a table tidying task with proactive dialogue, interruption handling, and task status checks, so the sequence reads like a storyboard of think, act, and respond. The color tags highlight roles: human instruction, visual observation, embodied reasoning, low-level action, and robot response. So, Figure 2 shows how the system splits brains and hands. Robix handles thinking and talking, and the VLM model executes atomic moves. The top row streams human instructions and camera observations, which Robix turns into a think and action sequence and timely verbal responses. Dashed arcs indicate the loop that ties perception to reasoning and to commands. This layout matters because the separation keeps dialogue and long horizon planning stable while low-level control stays reactive. So Figure 3 lays out the pre-training diet, which means the model learned from diverse tasks that teach spatial awareness, grounding objects and images, and step-by-step task reasoning. The top band targets three-dimensional spatial understanding, which is estimating depth, motion, and object boxes from two-dimensional views. The middle band covers visual grounding, like boxes, points, counting, and visual prompts. The bottom band adds task-centric reasoning and general multimodal skills so the model plans and chats coherently. Okay, Table 1 summarizes how the unified model stacks up across public vision and language benchmarks, which matters because it shows broad gains in spatial understanding, grounding, and task reasoning. This table presents robotics-focused scores on the left and large commercial models on the right. The three-dimensional spatial block shows consistent improvements over the QN backbones. The visual grounding block reports big jumps on LVISMG, meaning better object localization. The embodied task-centric section indicates stronger step planning under varied instructions. Wrapping up, two takeaways stand out. A single vision and language model can coordinate reasoning, planning, and dialogue for real robot tasks, and chain of thought plus reinforcement learning delivers reliable long-horizon execution with interruption handling and common sense. The broader implication is simpler, more capable embodied systems that generalize across messy, human-centered workflows. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.